Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students. Today we are going to continue with Class 10 Science Part 2, Chapter number 5 towards green energy. Topics that I am going to cover during this session are hydro energy based electric power station, wind energy based electric power station, and solar energy based electric power station. Electricity generation based on fossil fuels like coal, natural gas, and nuclear fuels like uranium and plutonium, they are not environmental friendly. It means that if electrical energy is generated using these fuels, it can lead to environmental degradation. Like burning of fossil fuel causes air pollution, global warming, acid rain, etc. It causes problems related to health. Fossil fuels are also non-renewable source of energy, so it will deplete in future. Nuclear power plant releases nuclear waste which is harmful, and its disposal is a big challenge before the scientists. Considering all these points, it can be said that energy generation from fossil fuels and nuclear fuels are not environmental friendly. So what is the other alternative? The other alternative is green energy. Electricity generated from water reservoir, wind, sunlight, biofuels, etc. are examples of such methods. The energy resources that are used in this type of power generation are never ending, that is, they are perpetual. Moreover, use of such resources does not pollute the environment. Therefore, energy production through these sources can be called environment friendly. The use of environmental friendly ways to produce electricity is known as green energy. The world is now heading towards green energy. We will study 3 electric power generating stations which are based on green energy, and they are as follows. Hydro energy based electric power station which will make use of water. Wind energy based electric power station that makes use of wind. And solar energy based electric power station that uses sun's energy, that is solar energy. Hydro energy based electric power station. Kinetic energy in flowing water or the potential energy in the water reservoir is a renewable source of energy. In hydroelectric power plant, as shown in the picture, the potential energy in the water stored in the dam is converted into kinetic energy of water. Fast flowing water is brought from the dam to the turbine at the bottom of the dam. The kinetic energy of the flowing water drives the turbine. The turbine in turn drives the generator to generate electricity. Here you can see the water from about middle of the total height of the dam is taken to the turbine. Let us see the block diagram showing different components of hydroelectric power plant. Water reservoir with potential energy, where the potential energy of the water is converted into kinetic energy to drive the water turbine, which in turn is connected to the generator, which generates electrical energy. Energy transformation in the hydroelectric power plant can be shown as follows. Potential energy in the water is converted into the kinetic energy of flowing water, which in turn is converted into kinetic energy of turbine, and finally it is converted into electrical energy. Advantages of hydro energy based electric power station. Since no fuel is used in this purpose, surrounding environment is not harmed. If there is sufficient water in the dam, electricity can be generated whenever needed. Although water reservoir is used for power generation, it can be replenished during rainy season, leading to uninterrupted power generation. It has few disadvantages as well. Obstructing the flow of river water can have adverse effect on the biotic factors in the river. The backwater, due to storage of water in dam, may submerge villages or towns as well as forests and fertile lands near the dam. Picture shows the schematic diagram of wind energy based electric power station. The kinetic energy in wind has been used since long time for lifting of water, for driving flour mill, etc. The wind energy can also be used for electricity generation. The machine which converts the kinetic energy of wind to the electrical energy is called a wind turbine. Over here you can see in this picture, this is a wind turbine. As the wind strikes the blades of the turbine, the blades rotate. The axle of the turbine is connected to the electrical generator through a gearbox. The function of the gearbox is to increase the rotations per unit time. Thus, the rotating blades drive the turbine and the turbine in turn drives the generator to generate electricity. Various stages in the wind energy generation system can be shown as wind with required velocity is used to drive the turbine. So, wind turbine with the large fins drives the generator, which in turn generates electrical energy. Now, here the kinetic energy in the wind is converted into kinetic energy of the turbine, which in turn is converted into electrical energy. Let us see the advantages of electric generator based on wind energy. The efficiency of this type of power plant is higher than that of the power plant based on coal. It causes less amount of pollution. And it is also a renewable source of energy. So it is available in ample amount. Solar energy based electric power station. In this type of power station, solar photovoltaic cell converts the solar radiation energy directly into the electrical energy. This is called solar photovoltaic effect. The electrical energy that is generated through this energy transformation process is DC in nature. This DC electricity can be converted into AC electricity with the help of inverter, and it can be used for the different appliances. So over here, the energy in sunlight is converted into DC electric power with the help of photovoltaic effect. Photovoltaic cells in solar energy. These solar cells are made up of special type of material that is called semiconductor, for example silicon. Now, if two solar cells are connected in parallel, as shown over here in the picture, the current generated from this combination is the summation of the current from an individual solar cell. You can see over here the total current is I1 plus I2. That is the summation of two currents from two different cells, that is cell 1 and cell 2. So we get I1 plus I2. However, the potential difference obtained from this combination is the same as the potential difference obtained from the individual cell. Thus, if two solar cells are connected in parallel, the potential difference from the two cells are not added. the potential difference is equal, that is V1 is equal to V2, which is the final potential difference. Similarly, if the cells are connected in series as shown in the picture, then the potential difference obtained from this combination is added. Over here, the potential difference across cell 1 is V1 and cell 2 is V2. So the final potential difference is the addition of V1 and V2. However, the current generated from this combination is equal to the current from an individual cell. It means that when the solar cells are connected in series, the current from the individual cells are not added. It is the same current, that is I1 is equal to I2, which is the final current. So, photovoltaic cells are connected together in series and parallel to generate electric current. This is one solar cell. By connecting many solar cells in series and in parallel, solar panel generating required current and potential difference are made. So this is one solar panel which is made up of several solar cells. And when several solar panels combine together and solar array is formed, as shown over here in this picture. In this way, solar array are used to generate electricity on large scale. The power available from the solar cell is DC in nature. So, in the appliances which need DC power, for example, electric lights based on electric emitting diodes, the energy can be directly used. However, since the energy from the solar cell is available only in the presence of sunlight, the energy has to be stored in batteries for use at later time. Most of the equipment in domestic as well as the industrial use, they run on AC power. So in such cases, the DC power must be converted into AC power using an electrical device which is called inverter. So this AC current can be used in many different appliances. We have seen that the thermal energy generated from coal and nuclear fuel can be used to generate electricity. Thermal energy can also be generated from solar radiation, and it can be used for electricity production. Picture shows the solar thermal based electric power station, where the solar energy is used to run the turbine, which in turn drives the generator to produce electricity. In this solar thermal based electric power station, there are reflectors. One reflector is shown over here in the picture. Reflectors reflect and concentrate the solar radiation on absorbers. And there solar energy is converted into heat energy. Using this heat energy, steam is generated with the help of the flowing water. And this steam drives the turbine, which in turn drives the generator. So, concentrators for collecting sunlight are connected to the absorbers for absorbing the concentrated sunlight, which in turn will rotate the turbine, which drives the electric generator to generate electric energy. Let us see the advantages of solar energy based electric power station. Since no fuel is used in this process, surrounding environment is not harmed. If there is sufficient sunlight, electricity can be generated whenever needed. Here we have finished the chapter. This is all for today's session. Thank you so much.